Hello guys, let's solve today's GFG POTD, largest BST. Given a binary tree, find the size of its largest subtree, which is a binary search tree. Your size equals the number of nodes on the subtree. So we are given a binary tree here, and we have to find the largest binary search tree. So we know that what a binary search tree is. Binary search tree means suppose okay, we can say that suppose we can tell that this is a binary search tree if left this tree is binary search tree and this tree is binary search tree, right part of left part is binary search tree and right part is binary search tree, and we can say left node value less than node value and right node value greater than node value. So left is a BST, right is a BST, and left node value less than node value and right node value greater than node value. So let's say binary search tree. So we have to tell the largest binary search tree. So for this one, we need I'll go to standard way. Actually, I created a own way of mine. It's not own way. I wrote a code for it. It worked for maximum test cases. It failed for some cases. I'll check it out again. But the standard way is first we should know how to find that we should write a function to find out it's a bias search tree or not. Means if we give this node, it should tell us it's a bias search tree or not. So we'll write a function whether it's a bias search tree or not. And for that, I'll give you a code here. See, let me explain it perfectly. See, bool BST means it tells us if it's a BST or not. Okay, right? So if root equals null, return true. First case, this first case tells us if root is equal to null, return true, right? Means obviously it's a binary search tree. And if root of data less than y and root of data less than greater than x, what does this, x and y are left and right values. Initially we give int min and int max actually. Okay, so initially we don't know anything, right? So that's why I give int min and max. If root data is less than y and root of data is greater than x, bool a means will iterate leftward and bool b means iterate rightward. Okay, so like that, we'll iterate everywhere. Means we should know regression properly to understand this. So this is the code for bool BST. Remember this. You'll understand it's easy only. It's a normal. See, let me iterate. Bool a equal to root of left, right? It will go. It goes to root of left. Um, and it includes x and the root of data. Means here x and it's root of data. Okay. So means like that you can iterate and you can check it's perfectly fine. So that's the bool BST. It checks the BST or not. Now what we will do is now let us discuss this perfect code. Means another function. We need to know about another function. What's that another function is? Number count the number of nodes. Means suppose if I give any node value, means if I give 6 here, if I give 6 node, should count and tell me the number of nodes in this complete tree, right? So that function we have to write. That's very easy. Base case if root equal to null, return 0, right? Root equal to null, return 0. Else 1 plus left comma right, function of left of plus function of right. So this is it. That's it. Nothing is there. Count number of nodes. That's another simple function, very easy function. If you don't know recursion, you can verify it in the online. You should know recursion properly to understand this. Now comes the big thing. See, now what we are telling is we have to find the largest BST, right? Largest BST. First, what we will do, we are here. So this complete tree can be a BST, right? So now what we will do is we'll check if this is a BST or not, right? See, we'll check first base case is that only. If root is BST, means this node is BST, then automatically I'll return count number of nodes in this BST, right? Number of nodes in the root. Okay, that's the case. But if it is not a BST, if it is not a BST, so this tree cannot be a BST, right? Obviously, this tree is not a BFT. So the answer may be in here or here, right? Left and right. So answer is here or answer may be here. In these two, left and right. So what I will do is I will return. maximum of left comma right. What left comma right is BST means largest BST. Largest BST of left comma root of left and largest BST of root comma right maximum, because the answer will be here or here, right? Anywhere it can be. So now it goes to here, it takes here and complete loop and it returns and this returns. So we'll get the final product here. So that's the code. That's the basic code. So let's code it down. I explain in the code between. So let's start this. Let's code it out. Yeah. So there are two functions, right? So let me write first function. Uh, what's first function is int nodes, means it returns a number of nodes in it. Okay, nodes. Let me uh, it's a basic. This is user. Okay, and return one plus nodes of root of left comma right, right. So left, yeah, plus nodes of right. Yeah. So this is the function of nodes. Next function we are what we are writing is check if BST are right. Right. So let me write bool. BST means it checks if it's BST or not. X comma into y. What are these into x and y is? They are left and right values. Okay. So base case is same here also. True. If x less than, yeah, root of value, root of data, and yeah, and y greater than root of data, then this is possible, right? Data. Yeah. Now what we will do is boolean means it checks left and right. So for left and right, okay, uh, comma x comma root of data. Maybe I should have done before b equal to bst of root of right comma uh, root of data comma y. So that's it. Yeah, return a and b, right? Yeah, means we are checking if it's BST or not. This node means we are checking everything, right? So if anywhere false is there, the dot would be false. Yeah. Else case return false. Yeah. If any one time false, everything is false. Okay. So here I told you already. If BST of we can say root comma here. What I am doing is I'm initializing values to int max comma infinite. So means BST initially we don't x and y, right? That's why I'm initializing int min and max. Okay. So okay, return. But we can say return nodes. We can return complete root, right? Once complete, yeah. Uh, Here else case will come. What is the else case is? So so return obviously largest BST, right? This only, this one. Same, but root of left comma right, right? So left comma, yeah, here I'll remove of right, yeah, yeah. So that's it, guys. I think it should work fine. Yeah, to submit it, I think it should work fine. Yeah. Yeah, it took me 9 attempts, but actually I derived a way perfect way. I'll discuss it afterwards. It's a means this is a standard way, but not means standard means maximum people are using this one. but I found out a way in a single recursion code. I'll tell it afterwards. So that's it for today, guys. Yeah. So